Good morning, everyone. I'm Jeremy Rubin. I'm the author of Check Template Verify, and then also maybe through accident, like an author of the CSFS BIP as well, even though I didn't really write the text. So, I have a difficult choice of building my company or getting covenants active. My company doesn't really use covenants, which might be a misconception. But I'm here today because I actually do want to get covenants active, so I'm here to push the button. Might be a little bit dark, but I think what we really don't want is to be, sitting here like a couple decades from now, like still like waiting and like talking about the same thing. I've already spent like half a decade talking about the same thing or more. I don't think it's an enviable position. So, although we want to go slow and not break things, I think we also want to see some action. To start off, I'm going to give a technical summary. And that's because there's a lot of people who aren't in this room watching on the live stream. There's also people who are here maybe joining into this community for the first time. I think for the most part, if you're attending this conference, you already know what Check Template Verify is. You already know what Check from Stack is. So I'm not going to bore you too much, but I'll give a high-level overview and try and keep it tight. So CTV is basically just a replacement for pre-signed transactions with a transaction locking script. It commits to almost everything in the transaction. It's had a stable specification since like 2019. And it has like use cases by itself for ARC, BitVM, vaults, payment pools, discrete log contracts, channels, federation deposits, staking, and more. Later on, it has a nice pathway for being upgraded, and it's easy to compute, so high performance. We have check from stack. This allows you to check a signature against data on the stack instead of the whole transaction digest. Very old idea. It's been deployed almost everywhere except for Bitcoin. There's a couple of small things that we could discuss and maybe do a little bit of bike shedding on of how it actually gets brought into Bitcoin. Not all those things really like matter that much. They can always be followed up with like later work if we want that specific feature. So any version of this is acceptable, I think, to most people who are working on check from stack. Alone, it has use cases for like BitVM, DLCs, and staking kind of things. Together, there's not like that much more that you get, except for one thing that we really care about, which is LN symmetry. But largely, these are independent changes. Together, they do one really important type of feature, which we'll talk about a little bit later. So now I'm going to just and I'm flying through because I've got a lot of content, but capabilities of CTV and check from stack. You're going to hear a bunch of other talks that will give more detail on specific capabilities, but I wanted to, give you a high level of like what the things are so that you'll know them when you see them again later. And the big picture is that like almost every protocol that's being used today or being proposed to be used today benefits from both of these opcodes in some way, shape, or form. So these are pretty good across the board. And you'll see I did in red ones that are probably going to say pretty like nice things about CTV and check from stack. In blue, I'm not really sure what he's going to say, but it'll probably have some good things, some bad things. So just for the maybe nothing at all. But I think for the sake of avoiding redundancy, I'm not going to try and explain everybody's talk. I'm going to leave them to explain their talk. If you're watching in a stream or in a record later, the reason I put the slide is like, go look at these. People have said interesting things about this topic, and there's a lot of other things. And if you look at this, you go, oh well, he didn't say this or that in his talk. It's because I didn't want to step on the toes of other people giving talks. All right, so the most basic thing for CTV is non-interactive protocol setups. So if you're doing something like a Lightning channel, you can use CTV to set it up without needing to exchange signatures in advance. If you're doing a timeout tree, ARC, a vault, all of these things, no more interactivity, no more pre-signing. You just set up the address and then you can send funds to it and it works. Protocols can have many alternative paths. It's not just like one CTV. It can be, a whole tree of different outcomes, and you can combine that with other conditions as well, like signatures. Another thing that has kind of gotten popular lately, but has always been, there in the materials, is you can do a kind of check input gadget. This lets you do any sort of CTV spend that has multiple inputs if you're using specifically. And by the way, can I get a water up here? If you're doing any like legacy P2SH or P2SH SegWit, it allows you to commit to different pieces of the executing program. This lets you, in some contexts, commit to spending with a specific other output, and then that is a useful power to have. All right. So another trick that you can use with CTV is you can have a CTV with multiple inputs, and you can underpay in the main output of how much funds you're expecting to show up there. This lets you set up like an option contract kind of thing. So an example where that might be useful is, let's say you wanted to non-interactively set up a channel, but you wanted your peer to also contribute funds into that channel. You could set it up as an underfunded CTV, and somebody could show up with funds later to fully fund the construction of that channel. Check from stack enables a basic form of delegation. So you can have a script that is signed by Alice, but instead it could become Alice signs a key, and then that key then signs the transaction. So it would enable you to maybe have a cold wallet that is just authorizing a key in your hot wallet to do something later, lets you template scripts out. You can take that trick and you can do something called key laddering that allows you to not just sign one element of data, but allow you to sign multiple elements of data together. So you could sign like a whole argument pack, and through key or signature laddering, it allows you to sign multiple different packs of arguments. If you didn't use this technique, just use checksum from stack by itself, then you would sort of always be signing the power set of all the arguments that you signed. So this lets you do it in a way that you commit to individual bits, which is important for a lot of protocols like LN symmetry, where you might want to commit to the next transaction and then some other metadata that you want always bound with that as well, or maybe a sequence that's not an nlock time. Checksum from stack lets you do lookup sets. So you can kind of implement a Merkle tree that with a trusted setup, but it's much more efficient. So for some applications, if you have a trusted setup, that might be a good use of checksum from stack. It also lets you do that using key laddering as like a function table. So you could implement using checksum from stack and a trusted setup, like an arbitrary function of two 16-bit numbers with a big precompile time. That might be useful in certain applications. You can also do cross-leaf data passing. This is the trick that's used in BitVM. You have some leaf 0 that is a function of some input data and checks as a fraud proof that the computation was not correct, enabling some punishment if you didn't do the correct computation. And then when you commit to the result of that function in leaf 0, you can then have leaf 1, which reads that output as an input and then does some other function. So it lets you do some sort of functional chaining across leafs. Also across different outputs, you can do entirely different UTXOs can use the same as like a global lookup space, and then compute a function in between an argument in and an argument out. CTV and checksum from stack let you do ratchets. Ratchets are the core of how LN symmetry works. So if you like LN symmetry, you can implement a ratchet-like protocol. You can also do anti-equivocation contracts, aka sign once. So you can say, if this checksum from stack key ever signs 2 values, allow punishing a bond somewhere. You can also make transactions that once you've seen a transaction in the mempool, any second transaction that you see signed anywhere allows that transaction to be canceled or punished, or maybe you to claim some funds. This would allow you to maybe set up like an authenticated reuse or zero conf safe address with a peer. So there's some interesting contracts you can build out of that. You can also detect SIG hash flags. So you can look at a signature, and there's a certain subset of cases that you can detect which SIG hash flags have been used. This is also useful with CTV. You can detect if particular. Actually, you don't need a CSF from that, but something that you can do anyways. So actually, you can use checksum from stack for that. It can let you detect if you're using any script SIGs, so any like legacy inputs that have input data. This one's also something you can do is you can have some CTV tree of things that are happening, and then you can have like a terminal node that loops back either to itself or to an earlier thing in the tree. That requires a trusted setup, but there's no dynamic state in it either. So it's just a simple state machine that can play itself exactly over and over again with a trusted setup, which is maybe interesting in some contexts. There's a more powerful version that you can do with any prev out that is not really possible, just CTV and checksum from stack. So that's a lot to say, but I wanted to give that overview because you're probably going to hear about these various techniques later on. And now you have these slides you can reference to sort of learn more about the techniques people will be using for the protocols they're building with check template verify and checksum from stack. In terms of how we got here, that's the talk I gave last OpNext. So if you want that content, you should go watch the talk that's already been recorded in this venue of minds. But instead of going over how we got here, I'm just going to leave you some key observations about like where we are now. And now maybe Greg will not be mad at me. So then basically we have in this moment protocol theorists who historically haven't liked CTV. It's been 6 years and there's really not something that's like concretely, tangibly better. There's been a lot of attempts to make something better, and then that something better maybe ends up looping around and requiring CTV. It's a very fundamental primitive. So, we haven't really made something different. Same with checksig from stack. There's also been a number of cases where there's something that's better that's been defined, but then it still ends up requiring CTV, or it ends up being broken somehow. So if it ends up being broken somehow, it's no good and it's not really a replacement. There's a lot of application devs who, at first glance don't really love CTV, but then they try it and then it ends up working well for them. They also might say, oh, well, what we really want is X. And then they don't do the work to, actually try using X. And then once they go through the work of trying to use X, they realize that maybe X, whatever it is, like doesn't actually really fully work for the thing that they're doing. And maybe CTV does work, or at least works as well as, X would have worked. And then there's another case of people have tried something else and it works fully, but it ends up being cheaper to do it with CTV and checksig from stack instead. And one of the really big things that happened that sort of I think has driven this set of realizations is really the work around ephemeral anchors, where earlier on there's a view that CTV was really bad because of how you have to pay fees with it. It's so ugly, it's so awful. And then people have tried every other combination of paying fees, and it's also been bad and awful. And instead, we've seen the development of ephemeral dust and ephemeral anchors, and it works really well with CTV. It works really well for lots of other protocols people want to do, and people have tested it, tried it. It seems to be okay, and so that's taken a lot of the wind out of the sails of something else that paid fees differently would be better than CTV. So L-enhance is a proposal that is sort of what's necessary to make L-en symmetry happen. At its core, it really is CTV and checksig from stack. There's a couple other optimizations that would be nice to have, but they're just that. They're optimizations, and if they're going to require more conversation from the community, we could spend a long time doing optimizations, and maybe people have run out of steam on that. And if we want to just advance the conversation, the simplest thing is CTV and checksig from stack. But in this venue, maybe we can discuss and come to agreement that we really do want to include those if we're doing a soft fork. They're really simple. But maybe we don't. If we just do the two, then we're still going to get the core functionality that builders need to make these new protocols. So for CAT, and I probably could have spent a lot more time here discussing the trade-offs. I think a summary of where a lot of the engineering community is that if people want opmul, if people want op M31, TX hash, probably just give it to them. It takes time to design, but maybe just give it to them. But don't give it to them by giving them opcat, because if the thing that people are going to do with opcat is use it immediately to implement a bunch of other things that really seem to be opcodes, we should probably just design those opcodes. Because as a part of reviewing CAT, we also need to review the designs of how you'd implement those opcodes, and implementing op M31, which is modular arithmetic over a 32-bit Mersenne prime, is probably not a very like fun experience and might not be like the best security approach rather than just like designing it right from the get-go. Obviously, you can make that argument ad reductum of like, well, what do you want M31 for? What do you want this for? And then, we obviously don't want, Swiss Army knife or something. But I do think that, for CAT, it is that Swiss Army knife, and people are much more likely to, slice their thumbs with it than they are to, to make something useful. And then, further, the community at large is very concerned with like how much MEV might this introduce. And for CTV and checksig from stack, I think that concern is relatively low. We have Nadav Shesek, who's a very good protocol researcher in Bitcoin. He's kind of like, these aren't enabling the kind of things that are harmful. For CAT, it's clear that it does enable the things that people are saying might be harmful. it's a question, well, is it economic? Is it what users will do? Is it actually really a problem if people are doing those things? And I think that when I spoke to people, they really just want more research on those particular questions before we proceed. But in this venue, we can maybe reach some different viewpoints. But that's why I think, at least for now, it's kind of CTV and check sig from stack can proceed. CAT is maybe a little bit delayed until people have more time to research. And then where did APO go? I think that basically it's just dead. It's replaced fully by CTV and check sig from stack. And if you wanted something that was a little bit more efficient, there's some other opcodes that are really nice. APO is also strangely a bit more powerful than CTV and check sig from stack when used for LN symmetry, in that it enables something called spook chains, which are similar to that looping thing I showed you, but with the ability to combine transactions in a way that lets you have dynamic state over amounts. So there's maybe some weird things you can do with it. And it turns out that it's less efficient. The BitVM trick that you'll probably hear about more later also doesn't really work with APO. So for a wide variety of reasons, I don't think anyone's really advancing that, even though at a certain point APO was sort of slated to become the thing that gets into Bitcoin, and maybe even would have been a part of Taproot originally. So why am I giving this talk at all? I really just was opted out of a lot of the soft fork conversations. Mostly, I have a company to build. I have other things I'm doing with my life. And then some people started saying that I'm kind of being a gatekeeper, which I don't take kindly to. I think that I've experienced being gate kept in the past, and it really sucks when you just want to know what somebody thinks, and they say, I don't really want to get involved. It's too much work or whatever. It's like, well, I want to know what you think just for advice. I also want to know what you think because other people are saying, when I ask them, what should I do? They say, well, what does this person think? So I didn't want to be in that position. So I said, after getting requested, please say something. I said, I don't think anyone really cares, but I'm willing to do something if you think people care. And so the thing that I decided to do was to post on Twitter. So the biggest nothing burger someone can do. And I posted that on February 28th, I'm going to endorse a covenant upgrade plan. And that I'll provide mentorship and guidance as I can. And I had my own, favorite approach. There's a number of good submissions to that. And then I sort of reviewed what everyone had said. And as a part of that, we have maybe a little inspiration from Gloria is first decide what to build and then how to build it and involve everyone. What does the community want? Actually. And so let's look and see sort of just as a state of affairs right now, what does the community say? So we have the people from, there's definitely some negative, I haven't really been, convinced yet of this stuff. And then just if you look at the timestamps, I think I maybe cropped some out that would have been nice to have, but early February, sort of when I'm navigating this process of figuring out, I think you're underestimating it. And then Ekram, who I think is here somewhere and speaking later, it's let me know if I can help. This sounds exciting. And now a couple months later, we have actually, it turns out BitVM is entirely improved by CTV. So the whole BitVM community went from being a lot of no's, we don't really want it, to being strongly in support. We have Steven, who made a post of saying, what his ideal roadmap is. And it's pretty good. It's not originally what I had in mind that people would propose, but I think it gets something that naturally slots this community here into two tracks of trying to do the just rote engineering work to prepare CTV and check sig from stack, and doing the more experimental work to consider a great script restoration of what are the tools we actually want to give people to work with, and then later on some specific introspection that can make those things really ergonomic. And his posts around that plan have had a lot of great discussion across the board. And then also some other exciting things that he'll tell you more about today. We have people from Blockstream, so Sanka and Andrew, saying that it's going to help them with Liquid in some way, shape, or form if it were to be available, by making the federated deposits a little bit more secure and solving their rollover issue. We have people from the Lightning Network who've looked at it, and it's not universally loved. Some people don't want to implement LN symmetry, but for the most part, people are saying that they would be really happy to have it at least as an option or a tool, and to be able to build it if they want it. We have some, and I think a lot of this is focused on CTV because it's a little bit more controversial. But like, there's literally no one who's like, check sync from stack, I don't want that. Everybody just kind of accepts that is a thing that we've had proposed for a long time. It's never been like bundled with something. I think if somebody wants to really make the impassioned case that check sync from stack shouldn't happen, today would be like a really good day to do that. Otherwise, I think everyone basically is just like, all right, whatever is happening, that's going to happen. We have people who do vaults research, and not universally, but a lot of people who do vaults research, like CTV and check sync from stack. It's maybe not the end all be all of what they would want, but it's usually an ingredient in a long-term plan, or at least it makes some immediate improvements that could be used by like everyday hodlers, which I think is great. We have people who run mining pools who would use it right away for mining payouts, optimizing mining payouts, and who also believe that it should be on the activation path, and that these activation paths for CTV and check sync from stack can kind of happen in parallel. They're happening at the same time. At the same time is also one invocation of in parallel. There's not really a reason for either of these things to hold each other up. And I think that this is also somebody who has a lot of experience with soft forks, which is helpful as we move things forward. The Taproot Wizards, who maybe are notoriously memed as being like only wanting cat and doing whatever for cat, are actually like probably fine with this if it seems like it's actually going to happen. And many more. So it seems like across the builders, this is something that is universally people will adopt it if it's there. And I think that there are other dissenters who are here today as well, who you'll hear from later. And I don't really know how to assess. I agree that Twitter is not the only space. We're in another space right now. So, talk to people, gather feedback and stuff, figure out what the bubble is and what the bubble isn't. Whenever I speak to people who are building, they're pretty happy with having more tools to build with, especially if those tools are easy to work with and secure. So I think that, probably more people who are building want it than not. There might be some more like philosophical reasons that people might argue about, well, how should Bitcoin development work entirely? And I think we'll hear a little bit more about that later from some other speakers. I put together a Signal group. If you want to join it, I'll have this QR code up later again, so you don't need to like rush to your phones right now. I don't know. We can, if you want to discuss these things, there should be a place to discuss. So there's now a place to discuss if you're interested in sort of supporting some of these efforts. You can join up there. If you're not interested, you can also join there and you can tell us that we suck. So following the post of like, I'm going to endorse something, I did decide, Steven's proposal seemed like the most reasonable path that people would agree on. And my role, I'm not really trying to do the specific work of doing it, but I want to help other people fulfill that work. And to the extent that I can run a Signal group, that's my involvement, and review a PR, I guess. So this is sort of like the first item of getting this project done. And it's also really helpful if you are supportive to just like say something publicly about like why you support it and what it would do for what you're working on. I think everyone's busy with actually doing work that they can get done fully today, but it is meaningful to share like what you're excited about. I also know that some of the like wallet ecosystem is getting excited about being able to have like more user engagement. So there's a tool which I don't know if it's fully launched yet, but I think you can use it end to end right now, which is called whatthefork.wtf. And so if you're a wallet user, you can sign saying you're supportive of one proposal or another, which is kind of fun. These are all things in this audience. Like, let's just have these discussions. Like, this is the whole point of this event, is to have these discussions, to talk about this, and maybe we can develop more. I think that as Bitcoin developers, we're very careful to not make decisions in an environment like this, because the tent is always larger than we can fit into a conference room, and we want to be sensitive to people who couldn't be here today. But I think that there's at least a coordinating function of having people in the same place that we can at least agree of, hey, we're going to show up in an IRC room in 2 weeks from now and discuss some of this stuff, and try and move things along. There's code in BIPs to review. James O'Byrne has been doing a nice job of preparing some pull requests. Other people have been also contributing to that code review in prepping process as well. He's just leading the charge at the moment. I'm going to hold him to not entangling in internet debate. So debate him IRL, but don't debate him online. He's busy, working on the code. There's code review and testing. That's an important step. One thing that I've heard from a lot of protocol developers, so not like application developers, but maybe core protocol developers, is that they just want to be able to try out more demo apps. So I think if you have something that you've been toying with, if you can just get like a little README that's, here's how I can run the thing end to end, and you can see a transaction on a reg test or on Signet, I think that would go a really long way at moving things along. They don't want kind of the hand wave; they want some running code. And as Stephen points out, it takes a special kind of person to ponder on protocols using unavailable primitives. Most people are more pragmatic and work with the tools they have. So keep in mind that somebody who's putting this out, if you sort of like start harassing them and saying this isn't production grade, well, like, yeah, it can never be production grade until the product is on market. And then I think at that point, I think that would be where we'd see sufficient community buy-in. And if the code is ready, without doing any sort of activation logic, we could see a merge into core of the code unreleased. So it doesn't really impact consensus, but it's at least there so that we can then have the discussion. This is historically how Softworks has happened. They get merged in an unactivated, undeployed way. And then later on, the deployment is sort of discussed and formalized. But that's an important step if we're going to have these opcodes, is to get them integrated into core. And then schedule some release meetings to actually discuss, okay, when can we, coordinate if there's going to be an upgrade? And then, sort of select those parameters and timelines. I know people always want to know like what the roadmap is. I would say, at least from today, like seeing something in 2025 is like, it's possible. But in a couple months from now, it's probably like almost impossible, just very unlikely, with when releases are, with how long process takes to review things. So 2025 maybe still possible. If we delay too long, then it'll be 2026. And I think part of what's nice with this process is if you're interested in like the GSR like stuff, there's no reason not to pursue that, full throttle as well. Maybe that'll be ready, at a certain point in the future. Or CAT or whatever. So all that other research would still happen. This is really about something that is in more or less like a research done phase, how we could move it forward. And so, hopefully we'll see that, consolidation effort around GSR, study the MEV, reduce the tooling burden. So that's something with CAT. If you have something you're excited about with CAT, showing what it looks like with CAT and showing what it looks like with like one other opcode is a pretty good, thing for justifying that other opcode. And then I guess the last thing is somebody's got to make hats. I think every other fork has had hats, so I don't think I'm going to make them. Maybe I will, but if you want to, that's the Signal group. I don't think I have any time for questions, but I'll be here, and just want to thank everyone for coming and participating in what I think is a pretty important moment for Bitcoin.
Jeremy, could you repeat the question for the recorded stream?
Oh, yeah, sure. So the question is more or less, also, I think one thing I'll just add maybe procedurally, like if you're in the audience and you don't want your name said, you should say that. So Shore's asked that, one, he likes that there's a lot of like application code being written, but that can show the contrast between with CTV or without CTV. And that some of it's a little bit abstract. But what he'd really like to see is like these like really simple use cases, like payouts to miners using CTV, shown on like testnet or regtest or signet, where you can see, how does it actually work in practice. And I think that that's a great suggestion. He also pointed out that it might be difficult on testnet because everything confirms. You can maybe simulate non-confirming immediately by putting lock times in the payout tree, such that transactions can't be broadcast for some delay or something.
Hi. On Optech, it says that CFSS enables transaction introspection. Is that true? Is that something that how would that not enable recursive covenants?
I would need to think about the exact math. If you can, I don't think you can use check sig from stack for that. I'm trying to think if you have a check sig from stack clause and then you have a signature that gets passed in off the stack and the key is like 1 or something. Like there might be something. Yeah. That would be my guess as well. I think that if it did enable something, it would be very similar to CTV. But I don't think it does. I think that there's some reasons that doesn't quite work out. Got it. Okay. Yeah. So I think it doesn't introduce kind of a new introspection vector just by itself.